Hello and welcome to the friction video. Today we're going to be investigating the 6 laws of dry friction. You'll find those printed on page 78 of your course manual. First we're going to do a little bit of recap though. As we've already discussed in class, the frictional qualities of a surface of a material are caused by what you could consider as a microscopic mountain range on the surface of that material. Think of something like the Alps or the Pyrenees, where you've got these sharp peaks and troughs. And then when we have two materials come together, those sharp peaks and troughs at a microscopic level all interlock with each other. And that's why it's difficult to pull them apart sideways, because all those peaks and troughs are there interlocked. So that's the theory. On a microscopic level, that's what's happening. And on this video, we're going to investigate those 6 laws of dry friction and look at the effects different materials and different conditions have on the effect we have to try and part those. So let's have a look at the first law of dry friction. Friction always opposes the direction of motion or impending motion. And we can do this here, we can prove this here. I've got a block here with a leather surface on it, and that's against a steel surface here. And I'm just going to place a mass on there to show you the effects of this. I've got a spring balance. We looked at a spring balance the other day, so you're aware of these. Now, friction always opposes the direction of motion or impending motion. So the direction of motion I'm trying to create here is that way. I'm going to pull in that direction on this spring balance. And I want you to look at the gauge here and see what happens. So as I start to increase a force on here, you can see this spring balance is getting bigger here. So I'm recording 5 newtons, 6 newtons, just over 6 newtons, and it starts to move. There we go. So I got to 5 newtons. I'll get back to there again. 5 newtons, and there's no movement of that block on that surface. So our first law of dry friction. Friction always opposes the direction of motion or impending motion. Well, this is impending because it's not yet started. Now, just think about this for a moment. I'm putting a force that way. So what must that block be doing to stop itself moving that way? If it's going to be in equilibrium, not moving, there must also be a force going that way. And that's the frictional force between the surface of the block and this surface here. So there's our first law. Friction always opposes the direction of motion or impending motion. The second law of dry friction states that friction is proportional to the force between the surfaces in contact. Frictional is proportional to the forces between the surfaces in contact. I'll go back to this block here. Now, if I have just one mass on this block and I pull it, it takes a certain amount of effort, a certain amount of force to begin to move that block. You can see it's just moving now. Now, what's going to happen then if I add a second mass to the top of this block? Well, that's going to increase the force acting downwards, and it's going to increase that pressure between these two surfaces here. Is that going to be easier to move, or is it going to be more difficult to move? Well, here we go. Let's have a look. Oh, look here. Just over 10 newtons are we starting to move. The last one was 5, this one was 10. So that makes sense, doesn't it? That second law makes sense. Frictional is proportional to the force between the surfaces in contact. So if I put more mass on there, there's more force between the surfaces and there's more friction. There's more friction, we've just proved that there. So that's the second law of dry friction. The third law of dry friction is frictional force is independent of the contact area. Frictional force is independent of the contact area. Got a slightly different block for this one here. We can see that we've got a normal surface area on this side of the block. If I turn it over, you can probably just see a channel has been cut out of there so that the area in contact is half the area of this side. So this side's normal area, this side is half the area in contact. So we'll do the same thing again. If I place it on this surface here, I'm just going to add a mass to the top just to help show the force that's required. So if I very gently start to pull on this spring balance, and there we go, just 5 newtons and it's starting to move. Okay, now that was with the complete area there. So if I then turn this block over so that it's half the area, and place it back down. Now the last time it was 5 newtons. If the third law is correct, this should be roughly 5 newtons again. Yeah, there we go, just under 5 newtons. So it's roughly 5 newtons again before it starts moving. So there we go, that's the third law. Frictional force is independent of the contact area because we had the same force required to move it regardless of the surface area of this material. Okay, and that's the third law of dry friction. The fourth law of dry friction states that static friction is greater than dynamic friction. Static friction, of course, is before motion happens, and dynamic friction is after motion has happened. It's whilst it's moving. Okay, so I've got a different block on here now. So we're going to do the same again. So we're going to measure and see the difference. So we should see this spring balance. Now look at this bit here, the white bit where the scale is. What you should see a jump there. So have another go. Yeah, not so pronounced the second time. What you saw was a jump. So I had to put a lot of effort in, and then the block suddenly started to move. And then once it started to move, the effort was reduced, and you saw the spring balance start to collapse a little bit because it needed less effort to keep it going. So the first effort was to overcome static friction, and that needed more effort to get it going. The second effort, once it was moving, was dynamic friction, and that's where the spring balance jumped back like that because we required less effort, less force to keep it moving. So there we go. The fourth law of dry friction. Static friction is greater than dynamic friction. The fifth law of dry friction states that dynamic friction is independent of velocity. Now, I don't have any equipment to prove that, so I'm going to ask you a question instead. Dynamic friction is, of course, the friction whilst the block is moving. And this fifth law says dynamic friction is independent of velocity. So if I change the velocity of this block, friction shouldn't change. So let me ask you this question. Does the material change its property if it's moving slightly faster? Does the material change? Well, the answer is no. The material remains the same. So dynamic friction is independent of velocity. And that's the fifth law. The sixth law of dry friction states that friction depends on the nature and condition of the surfaces in contact. And normally you would go through this experiment and you would record the differences in friction between these different surfaces. Here there's a leather surface, perspex surface, softwood surface, and a hardwood surface. Each of those is different in nature and condition. So that's our sixth law of dry friction. Friction depends on the nature and condition of the surfaces in contact. And that concludes all of the 6 laws of dry friction, and hopefully it's given you a chance to look at the equipment you would have used had we not had COVID social distancing.